All right, today we're going underground. We're going to dig into a part of our world that's totally hidden from view, but absolutely essential to everything we do. We're talking about the tough, resilient arteries of our electrical grid, the unsung heroes buried right beneath our feet.
So just think about it for a second. Power cables, they don't just exist in some perfectly safe, clean environment. No way. They're buried in the dirt, run through massive industrial sites, and are constantly exposed to the elements. They have to deal with the threat of being hit by an excavator, crushed under immense pressure, flooded with moisture, even chewed on by rodents. So what's standing between all that chaos and a total blackout?
Well, the answer is a really brilliant and, frankly, super rugged piece of engineering. You could say that our electricity has its own hidden bodyguard. And here it is, the armored power cable. The name really tells you everything you need to know, doesn't it? It's literally an electrical cable that's wearing a suit of armor. This extra layer of metal is its shield, and it's specifically designed to protect those delicate power conductors inside from all the mechanical damage we were just talking about. These things are built for the absolute toughest places on Earth. Okay, so how in the world do you build a cable that can take that kind of punishment? Let's do a little virtual dissection. We're going to peel this thing back layer by layer and take a journey right to its core to see how it's all put together. So you have to think of this as a complete system, right? Each layer has a critical job, and if one fails, the whole thing is compromised. Starting from the very outside, you've got the outer sheath. This is usually made of a tough plastic like PVC, and it's the first line of defense against water, chemicals, and all that good stuff. Right underneath that is the star of our show, the armor layer itself. We'll get more into that in a second. Nestled inside the armor is the inner sheath, which is also called the bedding. It's basically a protective cushion. Then we get to the insulation, often made of a super tough material called cross-linked polyethylene, or XLP. Its job is to keep all that electricity from leaking out. And finally, right at the very heart of it all, is the conductor core, the copper or aluminum superhighway that's actually carrying the power. But here's the thing, not all armor is the same. It's not a one-size-fits-all deal. You wouldn't use the same shield for every type of battle, and it's the exact same logic with these cables. There's a whole family of different armor types, and picking the right one for the job is absolutely critical. So the one you're going to see most often is SWA, which stands for steel wire armor. It's got an incredible pulling strength, what we call tensile strength, which makes it perfect for just burying it directly in the ground. But if you have a single core cable, you have to use AWA, or aluminum wire armor. And there's a fascinating bit of physics as to why, which we're about to get into. Then there's STA, or steel tape armor, which offers fantastic resistance to being crushed. And finally, you have the more flexible wire braid armor, which is great for things like connecting to heavy machinery that might be moving or vibrating. Okay, so this is the really crucial part, the big difference between steel and aluminum. For cables that have multiple cores inside, strong protective steel wire armor, SWA, is the go-to. It's a beast. But you absolutely cannot use it on a single core cable. Why? Well, it's all about physics. The alternating current flowing through that one conductor would create a magnetic field in the steel armor. These are called eddy currents, and those currents would cause the cable to heat up, like a lot, and eventually fail. Aluminum, because it's non-magnetic, completely sidesteps this problem. It's a perfect example of how the laws of physics directly shape engineering choices. Now, with so much riding on these cables, literally our entire modern infrastructure, you can bet they go through an unbelievable amount of testing before a single inch is ever installed. This is where their reliability is literally forged in fire. And to put all this into perspective, what kind of power are we really talking about here? Well, some of these medium voltage cables are designed to handle up to 33,000 volts. Think about that. At that level of energy, there is absolutely zero room for error. None. So, to earn their spot in the ground, these cables have to run this brutal gauntlet of tests. They get hit with a high voltage test, or hit pot test, which basically zaps the cable to try and find any tiny weakness in the insulation before it becomes a huge problem out in the real world. The insulation resistance test makes sure not a single volt of electricity is leaking out where it shouldn't. A continuity test is simple but critical. It confirms the conductor is one perfect, unbroken line from end to end. Then come the really brutal mechanical tests. They get bent, crushed, and pulled to simulate a lifetime of abuse. And for those high-power cables, a partial discharge test can find microscopic flaws inside the insulation that could grow into a catastrophic failure years down the road. It's an incredibly thorough process. And, this isn't just some random checklist that a manufacturer makes up. This whole process is governed by incredibly strict international and British standards, like BS 5467 and BS 6622. This ensures that every single cable that passes has a certified level of toughness and safety that people can truly depend on.
So we've taken the cable apart, we've seen the insane tests it has to pass. But let's bring it all back home. Why does this super-engineered, over-tested cable matter so much in our everyday lives? Well, it's because everything, and I mean everything, from the life support machines in our hospitals, to the trading floors of the stock exchange, to the giant data centers that power our entire digital world, it all runs on a constant, stable, uninterrupted flow of electricity. Our entire modern society is built on the silent, rugged reliability of these unseen workhorses. So the next time you flick on a light switch or charge your phone, just take a second to think about the armored cable buried somewhere deep in the ground, quietly doing its job. And that kind of leaves us with a final question to think about. What other invisible engineering is out there, right now, making your modern life possible?